So this all is consistent with the Big Bang. And the formation of the solar system theory is called the nebular theory. And you need to know that name. You're often asked that name, the nebular theory. This theory states that after the Big Bang, a massive flat disk, that shape there, of dust and gas and so on, lots of pieces, began spinning in an anti-clockwise direction due to gravity. Okay, so it started to spin, and this was just as a result of what happened after the Big Bang. Eventually, particles in the centre of that nebula started to join together. And eventually this part became so hot, once it became big, gravity pulled more parts in, and this part became so hot, eventually nuclear fusion began to occur. And once that happened, the star started to give out, it became a star, and this is how our sun was formed and other stars are formed, and that started to give out heat and light. Round the outsides then, some larger particles, so there you have the sun, and round the outside, some of the larger particles then started to join together to form the planets. This happened at various positions in the nebula, and once you had a few particles joining, then gravity pulled more and more and more in, and the 9 planets were formed then at various positions out from the sun. The rotation of the planets is all, not only on their axes, is an anti-clockwise direction, but also around the sun is an anti-clockwise direction, because the nebula had originally rotated in an anti-clockwise direction. It is thought that light exerts pressure. The 4 planets closest to the sun therefore experienced more pressure due to the sun's light, and they formed into rocky planets. They became solids. However, further out, the 4 outer planets were allowed to expand much more, and they weren't pushed in as much, and they became gases. And that's why they were also allowed to grow far more in size, and they became the gas giants. What is a light year? Many of the distances in the solar system and the galaxies in the universe are measured in light years. We normally measure things in meters or kilometres, but because the distances are so huge, we measure them in light years. And a light year is a distance, and it's the distance that light can travel in a year. So how far is a light year? Now, our nearest star, which is called Alpha Centauri, it's actually a twin star system, and it's 4 light years away from us. So we're just going to do a quick calculation here to see how far exactly a light year is. So we know that speed is distance over time, and if we rearrange that, then distance is speed multiplied by time. Okay, so we're talking about the distance light travels in a year. The speed that light travels at is 3 by 10 to the 8 metres per second, or 300 million metres per second. And the time then we need to work out is how much time there is in a year. So it's 365 and a quarter days, 24 hours in a day, and it has to be in seconds, so there's 60 minutes in 24 hours and 60 seconds in a minute. And when you do that entire calculation, you end up with a number 9.47 by 10 to the 15 metres. Now that's such a huge distance, we can't even think about it. You don't need to learn this distance, but be aware that it is an enormous distance. A light year is a huge distance. Our nearest star to us in our Milky Way is 4 light years away. So it's 4 times that, which is really very, very difficult to comprehend. So that's our nearest star. So that gives you an idea of the sizes of the distances in the universe. They're absolutely enormous.